Hi everyone. In this video, I will give you an introduction to object-oriented programming. Specifically, I will use the Pokemon as an example and show you how object-oriented concepts can be applied to Pokemon game. To start with, I will explain why we need to learn object-oriented programming and how the OO concepts can be helpful in Python programming. So first of all, let me explain why the object-oriented concepts can be so useful for programming. So in the Pokemon game, there are many elements that work together to make the game playable. So for example, we have those Pokemon objects, and for each Pokemon, we also have their name, their gender, the CP, combat power, and HP, health, the types of the Pokemon, and the moves that the Pokemon can use to attack other Pokemons. Okay, and we also have items that can be used to change the gameplay for the player's advantage. For another example, we also have Pokeballs that can be used to capture wild Pokemons. So all these elements, the Pokemons, items, Pokeballs, are different components of the game that makes the game more interesting. And one important thing to keep in mind is these different aspects of the game are closely related to each other. So for example, this Combat Tower 75 belongs to this Pikachu object. And similarly, the hit point, health, 26 also belongs to this same Pikachu object. And these numbers don't belong to another, say, Mewtwo object, okay, because it has a different CP and HP. One more example, the Power 8.0 belongs to the Quick Attack, which is the fast move, which in turn belongs to the Pikachu object. And Power 65.0 is an attribute belonging to the special move Discharge, which in turn belongs to the Pikachu object. And these moves and their powers can be used to decrease the opponent Pokemon's HP, okay, especially the current HP. Okay. So this is how different elements of the game are closely related to each other. Now, let me show you why object-oriented programming can be very efficient. So suppose we have three Pokemons, Pikachu, Bulbasaur, and Mewtwo. So let's first let Pikachu attack Bulbasaur, decrease its HP by 1 for simplicity. And the Bulbasaur will in turn next attack Mewtwo, decreases its HP by 1. And finally, Mewtwo is going to attack Pikachu, decrease its HP by 1. So without object-oriented programming, this is likely to be the code. So because we have three Pokemons, and we have their names, moves, and HP in this example, so we're going to have 3 by 3, which is 9 different variables. Okay, Pokemon 1, Pikachu, move 1, Quick Attack, and HP 1, 26, for example. And Pokemon 2, Bulbasaur, move 2, 1 Whip, and HP 2, 20. Okay, similarly for Pokemon 3, move 3, and HP 3. So when we want Pokemon 1 Pikachu to attack Bulbasaur, then Bulbasaur to attack Mewtwo, and Mewtwo attack back to Pikachu. Okay, we have to write another 6 lines of code. Okay, print who is attacking who using what move, and what happens to the corresponding Pokemon's HP. Okay, so when writing these print messages and HP modification, well, we have to be very clear which HP, whether being HP2, HP3, HP1, and what Pokemon is attacking the other Pokemons. Okay, Pokemon 1, Pokemon 2 in the first example, Pokemon 2 is attacking Pokemon 3 in the next example, okay, and so on. Okay, so basically, we are using the variable naming to help the programmers ourselves to be clear about which variable refers to what elements. Okay, but inside Python, it doesn't know. Okay, these 9 variables are just 9 separate variables, okay, without any relationships between each other. Now, with object-oriented programming, the code becomes you see, cleaner and more organized. In object-oriented programming, we have, say, from line 8 to line 16 is called class definition suite, which defines the commonalities shared by similar objects. So in this case, we have a Pokemon class defined here, and any Pokemon object will have name, have move, and HP. Okay, so this is how we model the relationships between different elements in a game. Say, name belongs to Pokemon, okay? Move also belongs to Pokemon, and HP is also an entity that belongs to Pokemon. We can also define some attack behaviors of any Pokemon. Okay? So the class definition suite is like a template with which we generate individual Pokemon instances. Okay? So this part, line 20 to line 26, is doing the same thing as we see in the previous code. Okay? Pokemon 1 is created, who has a name Pikachu, an attack called Quick Attack, and who has HP 26. And Pokemon 2 represents the Bulbasaur with 1 whip as the move and 20 HP, and so on. Okay. So this time, we don't have to write lengthy code. Okay, we can simply write Pokemon 1 attack Pokemon 2, Pokemon 2 attack Pokemon 3, then Pokemon 3 attack Pokemon 1. Okay, because those message print statements and HP, the changes of HP, reflected in the attack method. Okay, one time. Okay, we just need to write this one time instead of writing who attack whom 3 times. The advantage of object-oriented programming becomes more obvious when you have more objects and your program becomes more complex. Let's say, for example, in addition to decreasing the HP by 1, now we implement a critical damage. Okay, so here we are generating a random number between 1 to 10. So if the random number is greater than 8, okay, which roughly 20% chance, okay, then we deal 2 damage instead of 1. Okay, otherwise we just deal the normal damage 1. Okay. And in addition, we also want to print out what happened to the target Pokemon. Okay, like Pokemon 2's HP has decreased to the updated HP after receiving the damage. Okay. So if we don't use object-oriented programming, then we have to add these additional 5 lines for each attack that took place. You see? Okay, so in the object-oriented programming, the same idea can be implemented much easier by just adding that additional 5 lines in the attack method belonging to the Pokemon class definition suite. Okay, you see? After adding this thing to the template, we don't have to change anything in the main code. Okay, we are still doing Pokemon 1.attack Pokemon 2, Pokemon 2.attack Pokemon 3, and Pokemon 3.attack Pokemon 1. Okay, because when these attack methods are called, your code will jump back to the attack template that you define in the class definition suite. Okay, so this piece of code is reused every time the outside code is referring to this .attack method, which is defined in here. Next, I will explain the syntax for class definition. So a class definition suite contains an initializer and other methods. The initializer is a must-have component, which initializes the values of the attributes belonging to the same class and objects belonging to this class. The other methods are up to your design. So these methods determine how the objects generated from the class interact with other objects. So up to your design, you can have as many methods that help you implement the ideas. So here's the syntax for the initializer and other methods. The initializer starts with the keyword def, followed by double underscore, init, and another set of double underscore. So this thing is followed by a set of parameters separated by the comma. And the first parameter is self, okay, which is kind of special. The self is a mandatory parameter representing the objects to be created from the class template. Okay, so I will give you an example later on what this means. And you can follow the self by any number of parameters that you need. For other methods, the syntax is very similar, except you can use any names. Now, coming back to our previous sample code, okay, you see, this is the class definition suite, and this part is the initializer for Pokemon class. Okay, and this initializer has, in addition to self, it has 3 parameters, including name, move, and HP. So what this initializer does is, when a Pokemon object is created, then this name value will be used to update the name attribute of the Pokemon object that is going to be created from the template. Okay. Similarly, the value in this move parameter will be passed on to the move attribute the Pokemon object has. Okay. This is a little bit confusing because I'm using the same typing for this part and this part, but you can replace them with A, B, and C, for example. Okay. So this is equivalent to my previous sample code. Okay. So again, when a Pokemon object is created, the parameter from A will be used to update the name attribute of a Pokemon object, represented by the self. Okay. As I said before, the self is the Pokemon object which is going to be created using the Pokemon class definition suite. Okay. Similarly, the value B will be used to initialize the move attribute of the Pokemon object, and the value of C will be used to initialize the HP attribute of the Pokemon. Okay. But I usually I tend not to use ABC type of parameter naming. So one suggestion is to use some meaningful naming while avoiding to be identical to the attribute naming. So for example, name str, okay, representing the name attribute should be a string type, and move, okay, for example, move str, that's the second attribute parameter naming, and HP, let's say HP is integer in our case, and HP int here. Okay, so name str's value will be used to update the name attributes, and move str value will be used to update the move attribute of the Pokemon, and finally the HP int value will be used to update the HP attribute of the Pokemon object. Okay, so this is the usage of initializer. So how to use the initializer? Here, Pokemon1 equal Pokemon. Okay, this spelling Pokemon is identical to your class definition keyword here. Okay, so I'm defining my class name to be Pokemon, starting with uppercase P. So this is called Constructor, a Pokemon constructor which pass on 3 arguments. Okay, where the first argument being Pikachu, and second argument being Quick Attack, and 26 being the third argument. When this constructor is used, the first argument Pikachu will come here, name str. Okay? The first argument Pikachu will be passed on to the name str attribute. Okay? In other words, the first parameter after the special attribute self. Okay, you got it? The quick attack value. Okay? This is the second argument in the constructor. The quick attack value will be passed on to move str, which is the third parameter in the initializer. Okay, the third parameter, or in other words, the second parameter excluding self. Okay, so self is quite special in the Python class definition. Okay, finally, the 26 value of 26 will be passed on to HP int. Okay, so eventually the Pikachu, okay, the string Pikachu will be passed on to here, okay, which in turn updates the name attribute of the Pokemon object that is going to be created. The quick attack string value will be passed on to moveStr parameter, which in turn update the move attribute of the Pokemon object. Okay, so after the line 25 is executed, it will create a Pokemon object, okay, with variable name Pokemon1, who has name value as Pikachu, move value as Quick Attack, and HP with 26. Okay, so this Pokemon 1 is a Pokemon object, okay, and this is equivalent to the self here. Okay, the Pokemon 1 is equivalent to self when Pokemon 1 is being created. Similarly, when line 26 is executed, a Pokemon 2 object is created who has Bulbasaur as the name value, Vine Whip as the move value, and 20 as HP value. And this Pokemon 2 is equivalent to self, okay, when the initializer for Pokemon 2 is being called. Okay, so actually this is the most confusing part of the class definition. Okay, by defining the initializer and using the initializer using constructor. Okay, so otherwise, the remaining part of the class definition is pretty straightforward. Okay, just defining as many methods as you need, okay, that implement your code logic. So this, for example, this attack method, okay, we also have the first mandatory self parameter, which represents the Pokemon who is going to perform the attack. Okay, and in this example, we have another parameter, target Pokemon, okay, because we want the Pokemon who is performing attack to target another Pokemon. So that's why I named the second parameter in this way. Okay, so when the attack method is called, this is what happens. Okay, first we print out a nice message, right? But here you can see I'm referring to the name attribute of the attack performer by using a dot reference, self.name. Okay, because self represents the Pokemon who is going to perform an attack. Okay, so we want the attack performer's name to be printed, joining who. Okay, that one is attacking whom? Its target Pokemon's name should be printed. Okay, by referencing the target Pokemon's name using dot reference. Okay, I can easily call what variables and what values should be printed. Okay, so self.name is attacking target Pokemon's name using what? Using self.move, which means the move attribute of the attack performer. Okay, so by using object-oriented programming, we can easily refer to the right object and the right value by using a dot reference. Okay, the dot reference helps you identify the attributes belonging to the right object. So after printing out that nice message, we decrease the target Pokemon's HP by 1. Okay, that's written in the line 17. And if a random number generated is greater than 8, which translates to 20% chance, then the target Pokemon's HP will be decreased by 2 instead, okay, a critical damage. Otherwise, the target Pokemon's HP is just decreased by 1. Actually, this is redundant. Okay, I shouldn't have line 17. Okay, probably it's a typo here. Okay, so and finally, we show the users what happened. Okay, the target Pokemon's name, okay, that Pokemon's HP has decreased to the updated amount of the HP. Okay, and this is what happens. Okay, this is what happens when you run the sample code. And let me run it. Okay, it simply shows messages about what happened. Okay, Pikachu is attacking Bulbasaur using Quick Attack, and Bulbasaur's HP has decreased to 19. Then Bulbasaur is attacking Mewtwo using Vine Whip, and so on. Okay, recall that in my main code, I never refer to the Bulbasaur, Pikachu, Quick Attack, 19, these values explicitly. Okay, I simply did Pokemon 1.attack Pokemon 2, Pokemon 2 attack Pokemon 3, and Pokemon 3 attack Pokemon 1. Okay? But these values are automatically referred by calling the attack method. And in the attack method, the specific values to each Pokemon is reflected by rendering the Pokemon object and using dot reference to get the values of different attributes. Okay? So this is the advantage of using object-oriented programming. Okay? Compared to these two non-object-oriented programming that I have shown you before, okay? Where I have to explicitly refer to Pokemon 2, HP 3, Pokemon Move 2, HP 3, HP 2, and so on. Okay? So this is quite complex compared to object-oriented programming. And object-oriented programming will make your code cleaner and more organized. Okay, so when you got more familiar with the basic concepts of OO, then you can extend the very simple Pokemon sample, the Pokemon sample class definition to more full-fledged Pokemon class definition that is used in my graphical user interface game. So as you can see, I have a type table to help me determine what type is more effective against another type. And I have far more attributes in Pokemon class definition, including the name, HP, current HP, okay, because the maximum HP and the current HP are different concepts. And CP, fast move, special move, weight, height, and so on. Okay. And the initializer is longer, okay, but it does a similar thing. Okay, just initialize all the attributes with given values. And other custom methods like change name, determining whether, what is the egg type, increase HP, decrease HP, more complex attack and damage calculation, and so on. Okay, but basically the template, the structure for the template is similar. Okay, method name, initializer, and so on. Alright, so I hope you like this video. If you like this video, please subscribe to my YouTube channel and also follow me on my other platforms. Thank you for watching.